How can we calculate the DPS of burn or poison items in the bazaar? Um, the math is actually quite interesting, at least to me, but I'll try to give you the quick notes at the top. So the first thing we need to understand, though, is that we're talking about effective DPS here. So the same item is going to do way more DPS in a 20-second fight than it would in a 10-second fight for burn and poison, right? Because they're damage over time, and that damage scales up more over time. Quite intuitive. So the first thing that you need to decide when you're calculating the DPS of an item is how long do you want to calculate the DPS for? How long do you think the fight is gonna go on? Um, so decide on a number. Now, a quick tip for the bazaar specifically: the storm comes in at 33 seconds, and the storm ramps up at 36. So between 33 and 36 seconds, the storm does about 25 damage, so next to nothing. But then from 36 to 37, it does a 75. And then 125 from 37 to 38, 175 to 25. So it kills you very quick. Between 36 and 40 seconds, but one of the two players is going to die to the storm. Um, but you might also think, hey, my opponent's going to kill me in 20 seconds if I don't kill him. So let me calculate my DPS over 20 seconds and see if I do kill him or not. So anyway, so decide on a time that you're going to be calculating the DPS for, and then what you need to do is calculate this, the number of full cycles that you're going to do. So let's say you have a 36, or let's keep the numbers low. Let's say you have a 12-second fight, and you have an item which has a cooldown of 4 seconds. Well, if it's a poison item, in the first 4 seconds, it's doing nothing. And then between 4 seconds and 8 seconds, it does one full cycle of poison. And then between 8 and 12, it does a second full cycle of poison. So the number of full cycles in that instance will be given by the total T for which you're tracking the fight, which in our case was 12, divided by C, which in the cooldown, which was 4. 12 divided by 4 is 3, minus 1, that's 2. So those are the 2 full cycles that you get. So that's how you get that number. You need to calculate this in your head for the card. And then the amount of poison that you do is given by this formula. So the DPS of your poison is equal to the number of full cycles times the amount of poison that you do divided by 2. And if we take an example, so with this card, over, let's say, 20 seconds, 20 divided by 3 is about 6 point something. 6.6 minus 1, that's 5.6. 5.6 times 8, that's like 40, 44.8, like 45 DPS, right? So you can do that in your head. But for burn, the story is a bit more complicated, because with burn, your damage over time looks like this. You've got these squares, which are sort of the bulk of your damage, and this is just the same formula as poison, right? Because you're just doing a bunch of damage. It works in the same way as poison, but in addition to that, you've got this amount here by which you sustain. And the thing about these squares actually is that they're a bit smaller than the amount of burn damage you're doing, because there's this fall off here. So these squares' height is not the amount of burn damage you're doing. But if you're doing so much burn damage where the fall off is pretty negligent, or you don't mind sort of ignoring it, then the formula becomes very simple. But essentially, you have one formula for this blue area, which is the first formula that I'll show you in a second, and this for this red part, that's a very similar formula to how you calculate poison. So I actually made a typo here. This shouldn't be B times P. This should be F times B. The number of full cycles times your burn damage. And we don't have this half here because burn damage is applied twice as fast. So actually, this is for the red part. This is the formula for each of those squares. And as I said, if you're doing enough burn, then you don't really need to worry about this fall off. You can just calculate the amount of burn you're doing. You're gonna overshoot, but it's gonna be by a very little bit. If you calculate it this way. For the sustain though, this is the formula right here, which if you want to be more accurate, especially in the early game, you want to be accounting for this, you can do it that way. But it's not just these two formulas, you need to know sort of how to use them. So let's say you have this board of cards, right? This is your source of burn. What you'll want to do is, actually this is a very complicated scenario with the numbers I've picked, because what happens is, if this is the chart of damage over time, then the first one that's going to trigger is this one. Actually, no, it's not that complicated. So this one's going to trigger at like 5 seconds, let's say, and then this one's going to trigger at 7 seconds, and then this one's going to trigger at 8 seconds. And then it's going to go on for a while, and then this one's going to like explode off the chart. So what you have is like this area of triangles here. And what you need to do is basically take the lowest cooldown of your burn items, which in this case is 5, and calculate this number here. This, if you want to be fully accurate. If you don't want to be fully accurate, by the way, you can just apply this formula, F times B, to each one of those items. And let's just do it quickly so that we can compare how accurate the rough estimate is versus the more accurate. So F times B for all of them, 8 seconds. Let's do it how many? Let's do 20 seconds, right? 20-second fight. 20 divided by 8 is 2.25. Minus 1, that's 1.25 times 12, which is equal to 15. So that's 15 DPS. And let me just move it down for space purposes. So 15 DPS. This is equal, and I'll move the equal sign because it's annoying me at the top there. Okay. 14 times 7, so 7 is going to be like 3 point something minus 1, that's like about 2. So roughly about 2 times 14, which is equal to 28. DPS. And you can see, like, even though the difference here is not so large, it's like almost, this card is almost twice as good. 14 every 7 compared to 12 every 8. Then we have this one, 7 every 5, so that's equal to 5, so that's 4 free full burn cycles. 3 times 7 is equal to 21 DPS. And then this one, 10, so that's 1 full cycle, so that's just 38 DPS. So not surprising that this is the best item out of all of them. So total DPS is equal to 38, 59, 79, 87, 97, 102, I think. So if we want to do it accurately, what we need to calculate this first is this, as we said, for 5 seconds. So the number of full cycles is going to be, for 5 seconds, is going to be 3 times 2c squared. So 5, 25, 50 times 3, 150 divided by 20. So just let me write it out. So that's equal to 20 divided by 5 is 4 minus 1, so that becomes 3 in the brackets, multiplied by 2 times 25, that's 50, divided by 20, that's 150 divided by 20, 150 divided by 270, so that's 7.5. So 7.5 DPS is our sustain alone. So we've calculated that. But the thing is that this card alone doesn't sustain, whereas this card alone does sustain. So what we can do is we can sort of just say, okay, this is handling our sustain, and once our sustain is handled, we can just calculate these 3 items DPS as we did before. So if we do that, we've already done the math. Let me just delete that. Well, that's equal to 21, 38... Right, so I'm taking this 38, this 21, this 28 becomes 7.5, and this 15 gets added here. So that gives us a total of 21, 36, 46 and 48, 60, 74, plus 7, 81.5. 81.5 DPS. So for these items, which are pretty early game items, like probably round 4, round 5, I mean 38 burn over 10 seconds, maybe is like round 6 even. But that gives us a DPS of difference of about 20. So this will give you a good approximation, and it's pretty fast. But this is the more accurate way to do it. So yeah, this is what you need. Basically memorize these formulas and also the full cycles thing, but that's pretty intuitive. It's these things that you need to memorize. And you can calculate the damage. Obviously with burn it's not a simple story. It's a bit complicated. So yeah. Now I'm just gonna get into the math and explain why these formulas are what they are. So if we look at poison, what happens is at the start of the fight, you apply some poison, then you apply more, apply more, apply more, and it stacks. And this area under the curve here represents the amount of total damage that we're doing. So what we can do is we can just calculate this area under the curve, or in this case under the stepped chart, and then divided by the time for which we're tracking the fight. So in order to calculate the area, we can calculate the area of a single one of those rectangles. That's just the height, which is poison, the amount of poison that you're inflicting, multiplied by the cooldown, because every 1 second of cooldown you're applying that much poison. So this area here we can calculate, and it's P times C, of course. And we then can calculate the number of rectangles that we have over a specific number of seconds. So over, like, let's say 36 seconds, that's 8 full cycles. And the number of squares or rectangles that we have here is actually the triangular number of 8. The triangular number of 8 is given, and I'm writing these in algebraic terms. So f is the number of full cycles. The triangular number of f is f times f plus 1 over 2. We multiply it by the area of the rectangles, and then we divide by t to get the DPS. If we rewrite only this f, so if we focus here, if we rewrite this f as t over c minus 1, that's all I've done. Then this minus 1 and plus 1 cancel out, which is kind of neat. It helps us calculate stuff. And then when we cancel them out, these two c's also cancel out, because one is a numerator, the other one's a denominator. And here, this one's a denominator, this one's a numerator, so they cancel out as well. And you get the final formula over a half f times p. And that's poison. That's basically all there is to calculate. It's pretty straightforward. And the formula is very simple. Now for burn, so I just got rid of that junk. I was recording a video earlier and I was doing some examples. So if we look at this graph, then we can get the area of these little triangles by doing 2c, which is the height. This is the amount of cooldown, the amount of burn that is lost. That's equal to 2 times the cooldown, because every second you lose 2 burn. And the width here is again 2 times cooldown, because every second you do 2 ticks of burn damage. So the area of the triangle will give us the burn damage that we're doing over that time. And we can calculate the area by multiplying these two things together and dividing by 2, which gives us 2c squared. And the number of triangles that we have is the number of full cycles that we're doing. So the formula here is just f times 2c squared to get the total damage we're doing over the sustain, divided by t, which is exactly the formula we had earlier. Now, to get this formula here for the amount for the red squares, what we need to realize actually, and I sort of misled you earlier. I said something that was kind of wrong. This here is equal to b minus 2c. And this here is equal to 2c again. Obviously, it's the same as this. So yeah, I don't even need to write it because we already have it there. And each one of those is also going to be b minus 2c, because here we're sort of counting this downwards fall and then this downwards fall, right? So it's 2c once, 2c twice. So when I was showing you the formula earlier, right here, this B shouldn't actually be B, it should be B minus 2C. But I hadn't introduced like what exactly C was or why we were doing it, and this is only the case for the first item of burn damage where you're doing. So like if I go to our example of 4 items, then if we didn't have this perfect item which completely handled our sustain, let's say that this was I need to go to orange. Let's say that this was 17 damage instead of 14. Then what you would do is you would do this same exact calculation that you did here, except for the fact that to these numbers here that we calculated, DPS, take this here and delete it, we would also add this remaining damage after the sustain. So that's 3 damage, and we would do the same calculation with 3 damage. So that is 2 full cycles or thereabouts multiplied by 3 damage. So that would give us an additional actually I shouldn't go to orange, 6 DPS that we need to add, and then we would sum up this 6 DPS as well. But again, I wish I didn't make mistakes, but I do. So sorry for misleading you there at the start. But now that we know the area of this square is 2c times b minus 2c. So that's represented right here. Again, we do the same calculation as with poison for the triangular number of the full number of cycles that we do. And the algebra is pretty similar. Again, we rewrite this f as t over c minus 1. The minus 1 and plus 1 cancel out. So that's what we've written here. Then this 2c can, or actually, in this case, this 2 cancels out with this 2, c with c, t with t, and we get the line below, which is this. And then, actually, well, that's where I do the cancelling. I don't know what I do between these. Oh yeah, I just cancel out this here. And then this, this, okay. And we get this final formula, b minus 2c. But yeah, so this is actually only correct if this item is the one that's tanking the sustain. So you choose one item which you want to tank your sustain, wherever the math is easier. You tank the sustain on that one, you do the calculation with b minus 2c, and then you do f times b for all the other ones. And if you already are sustaining the burn and you're thinking of whether you should add this one item to your board, then you should calculate the formula as f times b. So f times b in many ways is a more accurate formula. But yeah, a lot of nuance to explain at the top of a video. But yeah, anyways, I hope you enjoyed the math. I think it's pretty cool. Yeah, I'll see you guys next time.